So as soon as you see something like this in your exam with a cumulative frequency graph, which sometimes, if you ever asked to plot a cumulative frequency graph yourself, the key thing to remember is that you plot your cumulative frequency against the upper bound of each interval. We've done that in class, but in this case the cumulative frequency graph's drawn for you. The thing that's a little bit different here is that they've drawn two cumulative frequency graphs on the same set of axes here. They've got one that represents male runners and one that represents female runners. So the first question says a male runner is chosen at random, so straight away we're focusing on this line, the male line, rather than the female line. So a male runner is chosen at random. Find an estimate for the probability that this runner took less than 4 hours to finish the London Marathon. Now your first mark for this is just to say, right, 4 hours. My x-axis is actually in minutes, so 4 times 60 is 240 minutes, and you have to, using your ruler, you have to read off from 240. Now remember, so the first mark is just reading off from 240. You're getting your first mark by doing this. Because we're talking about a male runner, we go past this female runner line, we go up to the male runner, and then we read across. Now if you're really accurate here, it'll fall in between these two lines, but if that's 40 and that's 60, this one here is going to be 50, which means each one of these little squares is worth 2. So if it falls in between these two lines here, your final answer will actually come out as, well that's 43, but because it says probability, if you look, the line goes up and levels off at 100, so that's 43 out of the 100 runners, which gives you 0.43. A few things to mention here. If you read off along one of the lines rather than in between them, you get the answer mark for 0.42 or 0.44. So they do give you a little bit of room for accuracy there. So 0.22 to 0.44 is fine. You get full marks for that. The other thing is just to be careful, because it says took less than 4 hours. We're okay here. We read off from 4 hours and we saw what it was. Just remember in class we did somewhere it was you had to read off for more than something. If it was the probability that a runner took more than 4 hours, once I read off the 0.43, it'd actually be the bit above that I was looking for, so it would be 0.57 as your final answer. But in this case it's less than. We don't need to worry about that. We just need an answer between 0.42 and 0.44. So the second bit, so for part B, use medians and interquartile ranges to compare the distribution of the times taken by the male runners with the distribution of the times taken by female runners. Now you'll notice, hopefully, that this is 4 marks. If you ever get a question that asks you to compare distributions, just comparing it'll be worth 2 marks, and that'll be 1 mark for comparing the averages or the medians, and 1 mark for comparing the spread, which will either be the range or, in this case, because it tells you, the interquartile range. So a 2-mark question that asks you to compare distributions, 1 mark is for comparing the medians and 1 mark is for comparing the interquartile range or the range in some cases. But this is worth 4 marks because you've got to read them off first. So there are, if you go back to the graph, because there are 100 runners in total, your medians will be read off from 50. So if I read across from 50, I get the male median to be here. So let's try and work out what that is. If that's 240 and that's 300, then that's 270. This is not actually the easiest scale to deal with. If that's so, 270 is halfway in between them. So 240 to 270. That's a gap of 30 that's split into 5 squares. So 30 divided by 5. Each individual square is worth 6 people. So I'm going 240, 246. I'm saying that's 252. So I'm going to say male median is 252. Let's do the female median at the same time. So So again, there's 100 female runners. So for the median, I'm still reading off from 50, but I just have to go past. Where I read off from the male line and keep going to the female line. So read off from 50, and then if I go down from here, let's see what we get. So that is 270. We said each little box is worth 6, so I'm going to call that 270, 276. I'm going to come across here, I'm going to say the female median is 276. Now the interquartile ranges take a little bit more work because there's quite a lot of work for your marks here, but if there's 100 runners, your lower quartile, a quarter of the data, is going to be read off from 25. Now if that's 20 and that's 40, that's 30 in between. So 25, we're going to read off from in between those. So we'll read across from 25 for the male, which gets you here. Now if I call halfway between 180 and 240, 210, if each one of these little boxes is worth 6, then I'm saying that's 216 for the lower quartile for men. And then if I do the same for the women, I'll try and speed this up a little bit. I'm saying that is in between 240 and the next square, which would be, let me just make sure I'm doing this right. So I've read across, I've read down. I'm saying that's just above 240, but in between that and the next square, so I'm going to say 243. Now, there's going to be limits for accuracy here. They're going to give you a bit of leeway for accuracy. Once I finish this, before I stop the video, I'll just flash the mark scheme up and tell you what the limits of accuracy are, so that we can check that my reading off falls within those boundaries as well. So if your lower quartile is 25, your upper quartile is 3/4 of the data. So if that's 70, we're going to read off from 75, which is 3/4 of 100. So reading off from 75, I'll do these two a little bit quicker. So 75 to the men, and then I read down from there. Again, I'm sort of falling in between two lines here. So from 270, I'm going 276, 282, and then halfway between that and the next one. So I'm going to say 282, 288. Halfway in between that is 285. So the upper quartile for men, I'm going to call 285, and the upper quartile for the women, read off from 75. If you're doing this all by yourself, obviously you can fast forward the video if you don't want to watch me do each one of these individually, but if I read off 75 to female, that's 300. If each box is worth 6, that's 306, that's 312. So I'm going to say my upper quartile for females is 312. You might not have got these exact values. We'll check in a minute what the degrees of accuracy are. But your interquartile range, if you remember, is your upper quartile minus your lower quartile. So in this case, 285 minus 216 is going to give me an interquartile range of 69. So I've got a median, and I've got an interquartile range. And for my females, that is going to give me an interquartile range of 69 again. Okay. That seems strange that we're going to get the exact same interquartile range, but the mark scheme says you get a mark for at least one of the medians. So the men's has to be between 249 and 252, so I've just fallen in that range, and the women's has to be between 273 and 276, so I've just fallen within that range. And the interquartile ranges, you get your second mark for at least one of them, one of which has to fall between 69 and 73, so I've fallen just within that range, and one between 67 and 71, so I've fallen bang in the middle of that range. So some of my values are right on the periphery of what's actually acceptable. You just have to read it off as accurately as you can, and if you're really accurate, you will fall within the boundaries for what you were allowed in the mark scheme. So this now makes your final answer a little bit dependent on what your interquartile ranges are, because I can say for my third mark, to compare the medians, I can say that on average, because median is an average, the females took longer than the males to run the race, let's say. Now I'm making sure I put context in there, because it says in the mark scheme that to get full marks, at least one of your comparisons has to be in context. It has to mention like males and females and times. To get your fourth and final mark, I have to compare the interquartile ranges. Now, because I've got them both the same, I'm going to say that the interquartile range, the spread, is the same for both. So the spread of times is the same for both. But because there are, there's a range of values you're allowed for the interquartile ranges, you might get one of them being slightly bigger than the other. If that's the case, just say that. Instead of saying the spread of times is the same for both, you will say that the spread of times is greater for whichever one you get the bigger interquartile range. Okay, so there's a bit of leeway within the mark scheme for this one. Lots of reading off from a graph, quite time consuming admittedly, but there you go.